Hi guys, welcome to our presentation
on gas exchange
on plants,
fish and insects.
So the first topic we will be presenting would be, Chris, could you tell us? Alright, plants, my man, okay.
The stomata connects the air spaces inside the mesophyll. This allows gases to diffuse quickly into or out of the plant. An unobstructed diffusion route is especially important for carbon dioxide. Its low concentration in the atmosphere, less than 0.04%, means that concentration differences between the plant and the atmosphere are small. Oxygen with a much higher atmospheric concentration can diffuse easily through leaves even when stomata are closed, as closure is rarely complete. In well-watered plants exposed to sunlight, the stomata usually open to allow mesophyll cells to take up carbon dioxide. The cells then use the carbon dioxide in photosynthesis, creating a concentration gradient from the atmosphere to the chloroplasts, down with which carbon dioxide diffuses. Carbon dioxide diffuses much faster in air than in water. Therefore, it is an advantage for mesophyll cells to be in close contact with the air spaces in leaves.
Okay guys, we're doing gas exchange on the insects now, and Willis will be starting this topic off.
Terrestrial insects are microscopic air-filled pipes called tracheae, which are used for gas exchange. Air moves into the tracheae through pores on the surface called spiracles. Oxygen travels down the concentration gradient. CO2 from the cells travels towards the spiracles down its own concentration gradient to be released into the atmosphere. The tracheae branch off into smaller tracheoles, which have thin permeable walls.
Okay, so these tracheae go to the individual cells, and this means that oxygen diffuses directly into the respiring cells. So the insect's circulatory system doesn't actually transport O2. Air is moved in and out of the spiracles using rhythmic abdominal movements. And yeah, now I'll pass you over to Harry.
There's a lower concentration of oxygen in water than in the air, so fish have special adaptations to get enough of it. In a fish, the gas exchange surface is the gills. Water containing oxygen enters the fish through its mouth and passes out through the gills. Each gill is made of lots of thin plates called gill filaments, which give a big surface area for exchange surfaces. The gill filaments are covered in lots of tiny structures called the lamellae, which increase the surface area even more. The lamellae have lots of blood capillaries and a thin surface layer of cells to speed up diffusion between water and the blood.
Thank you for listening
and watching our presentation.
Before we disappear,
pass it on to the real us.
We have some exam style questions for you to answer.
So grab your pen and paper before we begin.
What are microscopic air-filled pipes which insects use for gas exchange?
Moving on to the second question, does CO2 diffuse faster in air or in water?
So the next question is, what is diffusion?
What are the plates inside the fish's gills called?
The answers are trachea or tracheae.
CO2 diffuses faster in air.
So diffusion is the net movement of particles from an area of higher concentration to an area of a lower concentration.
Gill filaments.
Hello lovely people, welcome to the wrap.
with Willis, Harry, Chris and Jirat. Now you better sit down, watch and listen as I take you through the gas exchange system. First of all, let's begin with plants. Quite a boring subject at first glance, but once you really get into it, it'll put you into a trance. You see, they first take CO2 in for photosynthesis. Now listen real close as I get into this. They need O2 for respiration, and the leaves are done well to make adaptations. Gas moves in and out through special pores, and these are called stomata, of course, and that is all there really is to it. Now listen as we get into the new bit.
Help insects with the gas exchange. They have air-filled sacs known as Tracheae. Air moves into the pores of spiracles, and insect's body works daily miracles. Down the concentration gradient CO2 and oxygen 2, they both diffuse. The trachea branches into tracheoles and then into cells, which are individual. The circulatory system doesn't transport O2, it uses rhythmic abdominal movements to do what it has to do.
Now let's move to the fish's gills and listen while I lay down some wrapping skills. The gill filament are covered in a lamellae which help for gas exchange any day. That is where we'll end the rap, but last but not least let me diss Matt Wilkinson, cause he is gay. Yeah, I said it, he is gay.
Right, I need to try and look up so.
Alright, hi guys, well... Oh shit, come on.
I feel so awkward right
Let's
now.
keep going. We're gonna
It feels horrible.
Okay. Hi guys.
We need.
Wait. I can read you out now.
No,
Come on.
Yeah.
So, second question. Okay, moving on to the second question.
Okay.
Does CO2 diffuse faster?
Moving on to the second question: does CO2 diffuse faster in air or in water? Do I need to say an easy one as well, or you guys?
No, do you want to give the answers?
Oh. Moving on to the second question: does water no? What was the question? No.
Just CO2.
Diffuse faster in air or water?
Yeah.
Oh, bro.
Second question: does CO2? What was the question? Listen, hey, sorry, lads. I'm not being very clutch. Does CO2 diffuse faster in air or water? Is what I said in the first place.
Second.
All right. Moving on to the second question: does CO2 diffuse faster in air or in water?
Alright, can be quiet, just be quiet. Okay. Okay guys, we're now starting to talk. Oh, fuck man. Fuck man. Jess. Shut up. Shut up. Okay guys. No, you want to do this? Do you want to do this or not? Harry, shut up, bro. Yeah?
I thought we're doing up and down. Huh?
You go up and down.
Up and down.
No, I'm not doing that.
Do up and down. Don't then.
Alright, fine, do up and down.
Yeah, right. Just press play then, Jirat.
That's going. Thank you for me, Willis. Oh, was that a shot for the pass? Running on together, bro. Oh shit! Good point. That's the worst thing I've ever done. Where you gonna go, Jirat? Where you gonna go? Huh? Oh no, you already got his eyes. I'm falling through the trap. When he turns again. Watch his eyes, Harry. Watch his eyes. Watch his eyes. That's a good for my legs, Harry. Watch his eyes. He's making it. Made him make the layup. Good D by Willis. Seconds, very long time. Come on.
Chain dummy.
Oh, that's not my bad. There it is. Oh, no, no. Screw. Oh, what was that? What? No, money. Shoot that. That would have been the perfect mistake. Oh, how did touch it? How did you go? Oh. Oh, Willis! Everything comes from the shop pocket, it thinks. The cast, the shop. Oh, we took it! Oh, no! Splash, baby! That's on film!